After we talked about explaining versus predicting versus describing, we're going to talk about where things move next. So just remember that I started out by saying that there's really monopolies in certain fields in academia, for example. Things were more dominated by causal explanation. In other fields, it was more prediction. In statistics, it was description. And this was a paper, the Explain Predict paper came out in 2010. And we're now 13 years later. Things have definitely started changing. So let me kind of talk a little bit about where things change. So currently in the social sciences and in management, I think still explanatory modeling and theory-based is the king. Most of the papers that we will find in the top journals are still about causal explanations. We see a lot more, for example, using experiments, right? So that's a relatively newer trend. And they're still trying to ask causal questions, just using these very large, big data scaled experiments. But theory-based explanatory modeling is still definitely the key. Prediction is getting there, but not in every journal and not in every community. It definitely has gotten a lot stronger, and I will show you more in it soon. But not prediction for the sake of prediction. Usually it will be prediction. So I'll show you in a minute a few examples. The distinction used to be very blurred. I think at least in the field of information systems, for sure, things have gotten a lot cleaner. If you look more in, I guess, social sciences, more psychology and that area, things are still a little blurred for them. So they still think if they're explaining, they're predicting. Prediction is going faster into the IS field than it is in some of the more social sciences, but it is moving in all of them, and you'll find interesting papers and prediction things showing up in different places. So things have definitely gotten better. One of the issues that used to be a problem at the beginning is that many researchers were just unfamiliar with predictive modeling. So I remember at the time people would say, listen, we really want to do prediction, but we just don't know how to do it. Like, how do we do it? And I said, well, use one of my textbooks. So we started teaching also in the PhD programs a little bit of prediction. There's more and more PhD students taking machine learning courses. They're available now in business schools. They didn't used to be available at all. So also there's a big issue of knowledge, a big knowledge gap that changed everything. So the question is, fine, you know how to do prediction, but the main question is, how do you use prediction not just for applications, working for a company and improving your predictions, how do you use it for scientific research? And that is a major question, an important one, because we talked earlier about the philosophy of science and how they came to the conclusion that both predicting and understanding are two important parts of science. So how do we bring the prediction back into the scientific development part, which is different than, again, generating predictions for profit or for whatever other industrial reason. So the easiest way to bring prediction in is just to measure the predictive power of an explanatory model. The minute you take your explanatory study and you have the data and you just kept a little holdout set on the side that you didn't use and estimate its predictive power, it can help with a bunch of things. It can help us with check how relevant this is to the actual context that you're talking about. And again, in marketing and in information systems, everything is very relevant. The studies that people are doing are not just hypothetical. They're trying to talk about a certain context and maybe system. So checking the relevance of the theory to practice, doing a reality check to see whether the predictions can actually help and be useful in reality, the predictions themselves. And the third piece, which is very important, is predictability. Maybe the theory explains very well, but when you come to predict, it's not better than just random. And we saw this in very big financial meltdowns when people thought they built these amazing theories, but at the end of the day, the predictions it was unpredictable. Whatever they were trying to predict was unpredictable. And if you're doing that, then what's the point? You're actually leading science in the wrong direction. So finding that something I can explain it on average, but it's not predictable is actually a very useful scientific discovery. Okay, so predictability is the third one. And in fact, in the paper, the 2011 paper in MIS Quarterly, that's called Predictive Analytics in Information Systems Research, we mapped out 6 things where you can use prediction, predictive modeling, and predictive assessment for scientific research. So one of them is about generating new theory. Now, you can't generate a causal theory from a predictive model, but a predictive model can discover a lot of interesting new relationships that are then good input for finding out potentially new theories. There's some areas where we'd have no theory at all. For example, when things move online for the first time, maybe there's no such physical thing in the real world. It just was born when it came online, and there is no theories about it. And then what do? So in areas where there's no theory, predictive stuff is very useful for a first way to start finding out some relationships and things that are happening. A second very useful usage of predictive modeling is for developing measures. And measures can be anything from questions to any kind of measure where you're operationalizing any kind of construct. So we have constructs that maybe traditionally we've been measuring in certain ways, but now with big data, we have a lot more new stuff. And sometimes it turns out that some measures predict better than others. So you learn about, wow, interesting, you know, all these three can be used to operationalize this construct, but this one predicts much better than the others. So that's an interesting way to compare between measures, not just in terms of the usual reliability and validity metrics that we had before. So developing measures, that's a whole new different way to help us kind of break into new measures. A third usage is when we have competing theories, and you definitely have fields like psychology where you can have two competing theories. They can explain very well both of them, and you have the researchers and communities fighting forever over whose theory is correct. So this is another way to try and disentangle and figure out which theory has better standing, just by using the two theories to predict the same new set of records and see which one predicts more accurately. That's the scientific method, right? You generate a prediction and then you test it and you can see which one works better. So it's not the only way to compare theories. It adds another new dimension to help you compare between causal theories. A fourth one, which I think is actually one of the most practical goals, is to improve theory. So when we have a theory, many times we'll see that a causal new paper will come up with a new mediator or a new moderator. Is very, very, very common, right? Well, if you think about the U-tout models that come out, someone will add a new variable into that model, and that's the whole contribution, and it's a whole new paper, and it gets a lot of citations. Sometimes you can discover these kinds of nuances by running machine learning predictive models, because they will pick up on some kind of a moderator that you just didn't theorize about. Maybe there's a subgroup of people in your study population that just behave differently and you didn't know about it. And you couldn't find it from your data. You didn't theorize about it. The predictive model will pick it up and then maybe it'll say, oh, wow, we actually have a new moderator here that's very important. So finding new moderators, especially, I think, is where predictive modeling can help in improving an existing causal theory. Assessing relevance, very, very useful, again, and that you could do just by taking the causal theory and computing its predictive accuracy on a holdout set, seeing how close the predictions are to the actuals, and seeing whether these discrepancies are meaningful or not. Whether it's close or far, of course, depends on what you're doing. If it's Likert scales and you're predicting, you know, threes when it's really sevens, it's very different than if you're predicting 3 versus 7 on some totally other scale of how many people live in the household or how many clicks a person is going to click. So you have to, of course, consider what's the practical relevance, but this helps you figure out whether your model actually has relevance to practice. Many times we see now journals even moving towards wanting you to implement things in industry or show that it's useful to industry. So of course the causal arguments are useful, but many times industry wants to use these models to predict. So by assessing the predictive relevance of this model, you could tell your industry partner, look, and you can actually use my model to predict the behaviors of new users, and it will be accurate as much as, and you give them the numbers. The last one is what I mentioned earlier, is evaluating predictability. Sometimes some things are just not predictable. It could be because the phenomenon itself is not predictable, but then that's a very dramatic statement. If you're building explanatory models for something that itself is not predictable, that's kind of dangerous. But even at the level of measurement error, sometimes the way we measure things, there's just too much noise in how we're measuring them right now, such that it's not predictable. You can't get better than random. So maybe the explanatory theory is good, everything is really good, but it's not good enough and nuanced enough to predict individual users. It's good for the average user, but nothing more than that. So those are the 6 types of contributions that you can make by using prediction. If you're doing causal modeling, either by doing a whole new predictive modeling with the same data or something like that, or by just looking at the predictive performance of your model, that can also help with several of these points. The paper that we looked at in our course here is Prediction in Economic Networks. It's a 2014 ISR paper by a group of authors that combine both explanatory people and predictive people, which makes this paper super interesting. I like this paper very much because it's probably one of the first ones to show up in the IS top journals that was really just about prediction. Although I should not say just about prediction, it's not a paper that you would just send to a machine learning journal, because it really tried to show how it is very relevant for the IS theory community as well. We talked about how this paper helps in developing measures. For example, they were trying to measure historical demand, and classically this is operationalized with Amazon data using something called sales rank. But these guys actually tried also something else. They tried price, and they saw that it didn't work. But that's an interesting approach for developing measures. They also tried to assess the relevance of an earlier causal study by some of these authors. And they also tried to assess the predictability by comparing their predictive models to just simple, random, or naive models, and show that modeling actually helps. A part of their paper towards the end tells and tries to create the linkage. So they say this paper contributes to the literature of prediction and networks, even though they're not directly talking about social sciences or management sciences. They talk about predictability. They talk about a secondary contribution is identification of network variables, such as PageRank and local clustering, that contribute to demand predictability. So again, about measures. And I also want to note that they're using constructs. Even though predictive people don't typically use constructs, they use constructs such as demand. Demand is definitely a construct. They use things like network clustering, which is a construct. You can measure a lot of different measures. So the language here is familiar to the people who are doing causal modeling. And they also talk about economic implications relevant to decision makers. Then they refer back to a causal model that some of these co-authors wrote, Oestreicher-Singer and Sundararajan from 2012. And they say, look, that causal study was different. They showed that the visibility of a link between complementary products is associated with significant increase in the levels of demand. And then they say, although this is likely a necessary condition for future demand predictability, it is not sufficient. So they explain why the previous model, which was causal explanatory, was not able to show predictability, and why their predictive paper is important to show the predictability of this phenomenon. So this was one paper that goes in the predictive direction, but links itself to causal theory through another paper that they did earlier on. Let me show you a few other more recent papers. So that was 2014. This is 2018. And this is in information systems research. Again, information systems research is one of the top journals that actually has more predictive stuff than other journals. MIS Quarterly has less than others. I think some journals, it depends on the editor-in-chief at the time and their openness to these kinds of things. So definitely the editor-in-chief at this time, Alok Gupta, was very open, and you'll see interesting papers here. This paper is called The Impact of User Personality Traits on Word of Mouth, Text Mining Social Media Platforms. Now, you don't have to read the whole abstract, but what they're trying to do is they're extracting new independent variables from text. So they're using machine learning to create new variables. And that is something pretty common in the new kind of machine learning and predictive stuff. You're using machine learning to create new IVs for you from text that you couldn't do earlier then. And then if you scroll through the study, you'll still see hypotheses, you'll see the models the same way that we saw them before. So this is one approach to using prediction for deriving new variables from data, text, images, right? All these new kinds of unstructured data that we weren't seeing before. Here's a little piece just to show you that the rest of their article looks exactly like the kind of causal studies that we're used to, having a regression model there and having all kinds of causal stuff and an econometric model identification, all the terms that we know from causal studies. Okay, here's another paper. This is a paper, again, in information systems research from 2021, very, very recent, predicting stages in omni-channel path to purchase, a deep learning model. Now, we see deep learning, it has to be prediction because there's no causal explanation with deep learning. And you can see that what they're trying to do here is they're trying to look at the journey of the customer, but they're trying to extract the journey using deep learning. So what they're doing is they're using prediction to show economic value. They don't have any causal stuff in their paper. What they're really trying to do is, this is the first study to use omnichannel data to predict various pieces of the consumer's journey. So if we had this notion of consumer journey, they're now trying to find more parts, new parts that were not in there. So here they're using prediction, and it's not about causality. What they're showing is economic value. Once we do this, we have more economic value. The journeys that we find produce more economic value. A little bit like the Dhar et al. Paper, where they showed that the better prediction by using the network statistics creates more economic value. So economic value is an important thing that these papers often use. Here's another piece from this paper. They say we extract a rich set of predictors from the online and offline channels and learn latent behavioral patterns from the data, enabling us to accurately predict consumers' purchase journey in the online world. To assess the incremental value of using this data, we compare the model with several baseline models. In addition, to determine whether we might benefit from using deep learning, we also compare our approach with several benchmark algorithms. Okay, we further examine predictive performance across different businesses. So it's kind of similar to the Dhar approach, different models, different comparisons and benchmarks, but it's a predictive approach. You can see what their models look like. So they're, again, no causal stuff. They look at economic significance and they look at value. That's how they're connecting themselves to the management field. Here's a super new one, 2022. It's called Getting Personal, a deep learning artifact for text-based measurement of personality. That's kind of interesting. So this paper really has no causation at all. What they're building is really just a predictive model or framework, I should say. And you can see what they're saying. The text machine learning space has bifurcated into two branches: feature-based methods relying on manually crafted human intuition, or deep learning language models that leverage big data and compute. The main commonality being that neither branch generates accurate personality assessments. So they're saying there are two teams of researchers, the ones that use the psychology theories, right, to craft what are the big five and all this. And then there's the language models that just run a deep learning, and none of them really get good results. That's what they're saying when you want to measure personality. So what they're saying is they designed a special deep learning architecture that builds in both the theory part and the deep learning part, so that they actually end up with much better predictions. And you can see they're saying at the bottom, using case studies in the finance and health domains, we show that more accurate text-based personality detection can translate into significant improvements in downstream applications, such as forecasting future firm performance or predicting pandemic infection rates. So although all they're doing is prediction, they end up tying it back to the importance of information systems in management. You can't just say, oh, we came up with this cool prediction algorithm, goodbye. right? If you're going to publish it as an ISR, you have to link it back very importantly to what's important to the information systems community. Okay, so I'll show you just two in MIS quarterly, last two. This is 2020, so also very new. It's called Enhancing Social Media Analysis with Visual Data Analytics. So you can see they're using visual data analytics and deep learning. So again, what they're doing here is they're using pictures. And the last one, 2022, very, very new, understanding medication non-adherence, people who don't take their medication, from social media, a sentiment-enriched deep learning approach. So what these guys do is they basically start with research gaps, which I think is interesting. So if you're asking how do you write a predictive, so they say the literature review that they did reveals multiple challenges and opportunities. First, health social media, a previously untapped data source for medication non-adherence, has the potential to reveal patient perspectives. Okay, so first they see that this literature is lacking information about how social media can help. Number two, existing methods have failed to accurately and effectively identify user opinions from social media sources. Deep learning methods are well positioned to address this technical gap. So they find a gap, no one's using social media, and nobody's finding what are the opinions that people are voicing about not taking their medications. So they're going to build a deep learning method that can help and extract these important information. So if we're thinking about building theory later on, they're kind of finding out some interesting variables. And you could say, notice the other part. So now when they have to justify why this should be published in MIS Quarterly, right? They say, our study makes the following contributions. First, we design a sentiment-enriched deep learning approach for reason mining, finding reasons. We evaluate this method in the context of blah, 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 blah. Our approach significantly outperforms baseline methods. So they're showing that their predictive results are good. And this performance is mainly attributed to the sentiments-enriched components. Okay. Then they say, second, we outline a social media approach. So they're introducing an approach, not just an algorithm, which is useful for researchers, to understanding patients' risky behaviors that's complementary to the commonly adopted survey approach. So they're saying, look, right now everybody's doing things with surveys. We're suggesting another approach that complements it. So this is very useful for doing research. Okay, and that's why these kinds of prediction-only papers can get and should get published in the journals that we're seeing right here. So, sort of close things up. We also read this editorial, 2014 editorial in this class by Agarwal and Dhar. And although this was almost 10 years ago, there's so many things that they said here that are going to continue going forward and are still very, very relevant. They talked about how do you evaluate now these new papers, right? How will we evaluate papers that talk about big data and use prediction? And they said, how should we as editors and reviewers evaluate such research? There's no simple answer to this question. And to a large extent, our standards and methods of evaluation will inevitably evolve as our experience with such research grows. So at the time, they said, we're not really sure. Yeah, novelty, rigor, all this is going to apply, but we're not really sure what's going to be the new criteria that come in. And from the papers that I just showed you and things that are coming in, here's what I noticed. One is unstructured data, text data, images, voice, are the most popular usage that people are justifying to write prediction papers in this domain. So by saying, oh, nobody ever used that data on social media because we couldn't process the text, or nobody ever used the images that were coming up. This is very useful stuff. We should bring it in. This can help our theories, right? That's one way to get a paper published in this way. The other common thing that I see in these papers is that they all talk about some either economic value or practical value, right? If it's healthcare, it's you've improved identification of, I don't know, some kind of a healthcare outcome. So having a justification that people care about in practice, a practical one. And the third kind of paper is you do see some papers with new machine learning methodologies like the one that I just showed you. but they always come back and tie themselves to how things are done right now in IS or in this field, and how this new methodology complements or improves the methods that are happening right now. So these are the three commonalities that I'm seeing in the latest papers that are happening. And I think definitely there's more and more of these prediction type of papers, and more journals are accepting these papers. You have to ask yourself when things will become too much prediction and we'll lose theory totally. And that is a really big danger, actually, because that's kind of what happened in industry. So my last slide is actually about what happened in industry. And when I wrote that paper, when I wrote the Explain and Predict, everything in industry was not doing, people were not doing prediction. They learned their stats 101 in the MBA. They knew how to do a linear regression, and they thought that that was a causal explanation. So they would build a model and say, oh, these are the inputs, and a 1 unit increase in this will change the competitor's behavior that way. Things were not, no one was using predictions, also because they didn't have the analytics and the setup of their systems, and the data was not in place. And then all of a sudden, industry discovered prediction, and everything is done just for prediction. So it's either recommendation systems or predictions, and everything there is just based on machine learning. There's no theory. Nobody uses theory in industry anymore, which is kind of sad and crazy, and why we're seeing a lot of big problems, right? So many of the ethical issues that we're seeing, so many of the big disasters that we're seeing are because everything is just machine learning and prediction. So that's a big problem. Things turned to 100% data-driven. Data-driven is good, but not 100% data-driven. Deep learning is now everywhere, and deep learning is very non-transparent, very prone to overfitting. It does amazing things. I mean, I love a lot of the things. ChatGPT is amazing. But we also have to be careful of changing everything towards these very automated machine learning approaches. Prediction is king, totally overappreciated in my opinion. People think that now what they're finding also finds explanation, so we have to be careful very much with that, and reminding industry that finding causes takes a lot more time and careful attention. All the work that goes into an explanatory study doesn't happen overnight, right? It's years of collecting information, and qualitative stuff is very important. We see a lot of A/B testing happening in industry, but the type of A/B testing that they're doing there, yeah, it does answer a causal question, but it answers what? Is this better or is that better? It doesn't answer why. And that's very different from the causal studies that we're seeing in our fields and the papers that we're reading, where people really get very, very carefully into things and what is the mechanism, trying to figure out what is the mechanism that's going on behind the scenes. So A/B testing is not the answer to causality. Yeah, it's doing some causal stuff, but it's not the kind of causal stuff that we're seeing in academia, and we should definitely protect and keep doing that stuff as well. So just remember, things have shifted dramatically. When I've given this talk in 2010 or 28, before the paper was out, I was saying nobody's doing prediction, and now it's like everybody's doing just prediction. So we need both of them. We kind of really need to balance between the two. If we just do prediction, we have just short-term solutions. We don't have much understanding. A lot of ethical issues are coming up. We have explainable AI. The word explainable is very tricky. It's not really causal explanation. It's just interpreting or opening the box on why certain predictions are generated. So the word explanation is kind of getting melted away and used by other communities. We have to be careful to keep explanation and theories still important, because they are important. We need to keep everything together. We need this circle of theory and practice and theory and data. If we lose one part, we lose the whole scientific method once again. So that was the end of this part 2. Very important, and I hope you enjoyed it.